Yeah. All right. I think we can. Can you see my Visual Studio Code?
Yes.
Okay. So yesterday I said let me change that Jolomi to my account. After changing to account, they said I should keep files. I lost everything. Meanwhile, they said that I delete and keep files. Because the only files I could recover are those are my desktop.
Sorry.
Although it has made the computer a bit faster though, but my files I got.
No. Why can't you find your file?
No, they according to when I was doing it, so when you're changing to a different user, I wanted to
Mm-hmm.
delete that Jolomi's this thing. So then I said I
Mm-hmm.
should keep the file. That's a place they said keep the file. So I click it to keep the files. So then I said that I'm going to see the file, a folder on my desktop. That's in the new account that contains all the files.
Mm-hmm.
Then that contains all the files in that Jolomi's user profile. So then, but then when I now check, I now realized that it was only those files in the desktop that were there. The other ones,
Okay.
like the ones in
Um,
my downloads, most of the files in my downloads are not there. So, okay, I just have to.
and you don't need to back up your files. No?
Oh, it was on my Mac that I used to do all those stuff.
Okay.
My Mac, it's
Uh,
just
that, that's olden days way of doing things.
yeah. So I do have some of the files in my Google Drive though, but not the I don't really like not like I intentionally back up the files like that. And
Like me,
mm,
for instance,
mm.
I have my personal computer. All my every file in my document is synced continuously.
Okay,
So if you steal my computer today, I'll get all of them. If anything happens, it's in the cloud, that kind of thing. Although it's not all the folders that sync, but there are
yeah.
particular like downloads is not synced. So
Yeah, that's the thing. Most of my file, because I just went to that time now, because I was thinking I would just use the laptop for a while. So I just used downloads to put everything. And
mm,
download was completely ignored. In fact, instead it was
right.
documents and desktop.
The document was preserved, right?
Yeah,
Oh, that one's supposed to be preserved. That's
yeah,
where they assume your documents
yeah,
are.
yeah. I didn't just think about it at all. So documents was preserved, and then the other ones that were they were all gone. Anyway, they're not files I can. I don't, of course, I don't really have most of my important stuff shared on Google Drive. So that this all the books that I downloaded, I had to like find them again. All right. Okay. So let's start. So last time. So any question? Let's say about exception. What can you see on my on the screen now? Can you see my? What can
Visual
you see?
Studio.
Okay, just okay. That's fine. Just to be sure. Okay. So last time we went through some advanced stuff in
Okay.
Python, some interesting stuff like exception. I think we did exception. So any question about exception? Can you write your program now and then include uh exception? For instance, let's start by taking a look at this. Uh, remember when you're writing your model, so it's a good idea to write at the top what your program is about. Okay, and to do that, you use this doc string. Okay, you can say maybe say I can just say exceptions. Python. Okay, so when you use a doc string like that, so basically that's it can if developer looking at your code can clearly just see that something about the content of your file or your module. A module is just a Python file. Okay, but we're going to still learn a bit more about it. But basically, writing a doc type that is really encouraged and is important. Okay, so that's why I'm just writing this simple stuff and say exceptions so that this anything I'm writing here is about exception. So if a developer just look at it and quickly just see from a doc type, so that this file is about exception. And also when you can, it can also be printed out when you when we do underscore name, but later on we'll get into that. Anyway, so yeah, about exceptions. Okay, let's take a look at example of existing exception in math in Python. When you say from math import square roots. Okay, I think that's something like this in math. Can you see what I'm typing very well?
Yes.
Okay. So let's just try something here and say results. Say square root of, no, let's say 45. So I'm just going to print it out. Can I move this thing away from here? So I'll just print the results. Again, it always makes sense when you're printing out stuff, right? You don't just print a message that gives you information about what you're printing. So instead of just saying result directly, I'll just do this. And of course, I always prefer this one method of printing the F string. Results. Okay, let's see what we get from this one. So I'm going to save it and say Python exceptions. Okay. So of course we got an answer here, okay, which is valid. Now, what happened then if we, instead of this, I say this? So from what we did last time, what do you think will happen here? So without running it, what do you think will happen?
There will be error.
No, like, yeah, error, but what kind of error? Or why is it going to be an error? So what? Why should it be an error? Why should it be an error?
I think that should be type. Is it type error or no? I think type error because the 45 is a string instead of a.
Oh yes. Oh yes.
Yeah.
Okay, let's see what it gives us. Of course, we have a type error. Okay. Because this function here, this type error is actually an exception. Okay, so now this Python code is trying to run the program, and then it encounter some unexpected circumstance, in this case, some unexpected value. So it was not expecting a string. Okay, but that's what it encountered. So in that case, the program just crashed and it ended the program. So let's say I have something here. I want to print out something here. Print calculating. Okay, just this, right? Let me run it again. Do you think that this will be printed on the screen? Anyone? Hello, can you hear me?
Yeah. It won't print the calculating and the rest because the type error at the result is bound to square root of string 45 will exit the program, and that's type error.
Yeah.
So the rest won't execute.
Okay. Yeah, that's fantastic. So whenever your program encounters situations like this, ordinarily it's going to crash. The program is going to crash. I'm sure you have seen something like this before, like index out of range, file end of file error, and then that's the end of the program. It doesn't continue. All right. In the same way, this is what happened here. And the reason is that, let me just run it first and see. So I'm going to clear the screen to have some breathing space, as I like to do, and then I do exception again. So you see, it just ended as soon as it encounters this exception, right? It ended the program stop. So this calculating is not. And the reason is that the exception is not handled. Okay. So whenever there's an exception, when we're writing our code, we make sure that we handle exceptions. Okay. I will find out if I'm using the API. In this case, I'm using an API, something that is written by other people for me to use in my program, right? I'm using this. And for me to even use it confidently, I need to know about the program. So I need to know about the API very well so that I can handle the exception that this API may throw in the process of executing within my program, because the program is written by somebody. So the person is not there to tell you whatever, all right, how this program is going to work, or what will happen if somebody makes a mistake, like this mistake I've made here. Okay. It just threw an exception and then ended my program. What if I have some important code to execute below that? That means that that's just be the end. And I don't even give the user any opportunity to restart the program, all of that. So imagine you go to a cash machine to withdraw money and then you make mistake somehow, and then that's the end. So it not even allow you to go back and continue. I'll tell you, it just crashed the program and that's the end. So you have to now go and look for the person that wrote the program to come and, help you continue what you're doing, which is not nice. So at this stage we are, when we're writing program, we need to be able to specify our APIs, or especially if it's something that somebody's going to use, okay, or even what you are going to use later on. When you're writing your code, you need to write some doc string that people can really see what the code will do, the kind of session that is going to be thrown, all right, and also be able to handle it. Like in this case, so if you are using this without handling exception, right, like this, it means that you have been using the square root program blindly without really studying the API that has been provided for you. And that is the case for most people, because when you are starting, you just know that, oh, this one give me a square root of a number, so you just use it. But when you're using the program, you need to handle the exception with it, so you don't just use it, you handle the exception. So how do we then handle the exception in this case? So what we can do is to say this. So let's say I decide to have my own, or say I'll call it find. Okay, let me just call it root. Okay. So this root is going to take some value x, any value at all. Okay. And the idea here is that basically I just want to return the square root of x. Of course, you may argue that this is correct, which is in some cases, in most cases, correct. But let's just go back and see what happened here. So instead of just doing the square root, I'll just call it root. And then I will pass in the value, in this case 34. Okay, and see what happened. So if I do that, did I save it? No. So let me save it first. Not save. So I can so let's say, of course, it gives me that the square root of, okay. But let me just put it like this: the square root of square root of this, which is the number, in this case. Okay, maybe I'll just use some value here. 34. Use n, so I can have square root of n and have this. Okay, so that will give me better description of my output. Okay, so if I got 34, then that's it. Okay, now this is good. Okay, but what happens when this 34 changes to 45? Okay, and you now see that the same program gives an exception. All right, same program gives an exception. Sorry, just 1 minute and 1 second. Let me see what's happening. All right. Okay. So this thing about exception. Okay. Yeah. So let's continue. So you can see I still have this now, and that's because I did not handle the exception. All right. So let's see how we can handle the exception here. So instead of writing this code like this, you know that I already know that. Okay. One thing I can do first of all is to find out about what this person doing. Just 1 minute, 30 seconds. Oh, guys, I'm having some calls here. All right, so can you hear me? Can you all hear me?
Yes, yes, sir. Yes, sir.
Okay, okay.
Yes,
Okay.
yes.
So to handle this exception, right? Okay, the first thing I need to do here is, and this is a pattern you need to follow, right? So I'm going to just spin off the Python shell, right? So let me just clear. Okay, and just see something first and say import math. Okay, say help math. Let's see. Return of x, then doc. Okay, so let me just say from math import square root and say doc. Whether this is correct, but let's see. Name docs. It's not there. Okay. Okay. So this one gives me some information, but not really give me all the information that I need. So in that case, one thing I could do is to go to Python documentation to find out more about the square root. Okay, so that I know exactly what I'm doing when I'm working with the square root. Okay, so that it will show me, and then when I go to the documentation, obviously it's going to give me some things about this. It's going to show me a few things about the square root, especially the exception is going to throw. Okay, that's what gave me a knowledge about that. And having that exception in mind, then I will now come here and say, I will know that, okay, square root throws of exception. So I need to write a try and catch statement. Okay, try and accept. I say catch. Okay, in some language, you just catch, all right? So try and accept statement. And where you see that it throws a type of error called type error. Okay. Okay, so what I'm going to do, I'll say type, I will now put this thing here. Where is it? Result root. And what did I write before? Okay, so I'm going to now return the square root of, or maybe to make it easier, let's just do result first. Result equals square root of x. Okay, and then I'll just return the square root of x here. Return result here. All right. So now, in the case where I encounter this kind of error, right, which is type error, that is an exception. Okay, in case I encounter this exception now, what I want to do is just to assign x to be equal to -1, and maybe I can say here return dot. Okay. One thing I could also do is that I can come here and say result. Okay, let us do. Okay, return results. Okay. All right. Or maybe for now, let's just print it out instead. Okay, maybe return is fine. Just return. Return. Don't worry about the return statement too much for now. But basic idea is that I want this program to still continue. Okay, up to this point after the exception has been handled or has been encountered. Okay, so let us make it as simple as that for now. So the next thing I'm going to do is just to run it and see what happens. Okay, sorry, I did not save it. So I'm going to clear the screen. Okay, so it's giving me the square root of 45 is -1 because that's what it returns. Okay, so if we put x, okay, if we put result, okay, let's just return the result instead. I think that's actually the best way here. So I'm going to remove that and say result equals -1. Okay, sorry, this indentation stuff. Or maybe better off, can say unknown. Okay, so in that case, what I'm saying is that whenever you have this thing through this exception called type error, okay, I want the result to be unknown. So, and then continue with my program. All right, so let me put this here. Yeah, so I want my program to continue, so continue with whatever I'm doing. So let's run it again and put this. So you can see the program continued. It did not just cry, just say unknown, then it allows it to continue. And that's because I've handled. So you can see by using something simple as square root, yeah, is that you don't just use it like that. Okay, before now I've just been using square root just to get the answer right. But you need to be able to use it in such a way that you handle whatever unexpected case that comes with it, all right? So again, let's now do something like this. So we have had a square root. Okay, what if it's not even a number at all? It's something like this. So what do you think will happen here when I run this? Any idea? What do you think will happen?
It should still be a type error.
Well, it's an error, but it's not really type error. What's the name again? No, let me record the name.
Value error.
Value. Isn't value meant to be like it's an integer, but something is wrong with it, or it's I don't know. I'm not sure.
Okay, so
Yeah,
obviously,
This is a string.
obviously,
Yeah.
let's see.
I think
Let's
this
see
is
what
a
to
value
give us.
error.
Let's see what to give us. Yeah. So one of the answer is correct. So let's see what to give us. Unknown. And that because it's what is still a type error. Okay. Now the reason why this is a type error is because this expects only two types of values. Square root says only two types of values. It's either int or float. Okay. It does not expect, the other case, I know why you say the type error. It's just because when we did last time, I used the function. I think I was converting converting a string to an integer or so, right? And this particular function was, I think it was the int function. Okay, the int function expects you to give it either a number, an integer, or a numeric string. All right, that case is different. Maybe we should just review that case quickly again. Where I think I wrote a function, I called it convert, right? And I said something. Okay, even this one I now write convert a string to an integer. Okay, so it's important that we understand this thing very well. Okay, this one convert a string to an integer. All right. So, and what happened in this particular case? I said, okay, you can write in different ways. So let's just, since it's something we're just writing quickly. So I'll just say, I'll just return int s, okay, and then say except so let's say type error for now, and then I can say print. Let's just say, okay, no worries. I just return -1. Okay, just return -1. So in the case of this, right, if I call, so I'm going to just comment out this. If I print out conversion, okay, if I print out conversion, just to make it simple and say conv convert, and then pass n. Okay, pass n to it. Let's see what will happen here. So I'm going to put conv here. So the value that is being converted. Okay, so let's just run it and see. So in this particular case, you can see that we're having value error, and that's because this particular guy here expects two types of values. Okay, either a numeric string or just a number. Okay, so let's now change this to 45, and you see that we're actually going to get the right answer, which is 45. So convert it to an integer. So value error, you get the value error when you get first of all, to get the type error when the type is not the type that is required at all. Okay, when it's not the type that is required at all, it's not the type, like we have integer, you have float. But a value error, the type may be the correct, but it's not the type. It's not the type may be correct, but it's not the value is not correct. You understand? Like in this case now, the type is a string, but the value is correct because the value must be a numeric value inside the string. Okay, so even if and this particular case, the type is correct, but the value is not correct. Okay, again, when you say this, okay, the type is correct. Okay, maybe I don't know. Let's see whether the type is correct. See, yeah, it's correct. What if you have this 45.45 and you also see that again, the type is correct. Okay, so expect integer is expect a float and expect what a string, but a numeric string. Okay, so in the case where we had that thing like this, we had it like this, which you had something like this inside. Okay, let's see what happened again. We had a value error, and then the program terminated, right? It does not even allow us to print out this other thing here. So this is very, very important. So take note of it. So what we need to do? All we need to do is to include that particular type of error. Okay. So because you don't want to just handle one type of error, so you can include value. Sorry. Value. So I believe that this should have now taught you how you can say now, even if they throw an exception, the program can still continue and the program can still run. So whenever you're writing your code going forward, so don't just throw up your code out there or write it, So because in the real world now, you want to always make sure that things are handled properly. You want to write your code in a proper way, and you want to know. So even when you are also writing your own, let's say you are even writing. How about you are writing your own library, or you're writing your own functions that other people may use. Okay, so how would you handle that? Okay, let's say even for instance now, how would you, let's say we want to write our own version of so this is just basically we're handling the exception. How about us now raising the exceptions? I'm going to just comment out this. So as a developer, right, you need to be able to handle exceptions. You need to be able to also raise your own exceptions. So we're handling exception in functions like int and square root, because in square root itself, exception is being raised. Okay, let's see how we might implement square root, for instance. How might we implement if we have to implement our own square root? Okay, we can go ahead and there are a couple of ways to implement square roots. Okay, there are a couple of ways you can do that. There are standard way in computational mathematics that's being used to do that. Okay, so and one of the ways is just so you start with so let's say how you want to calculate the square root of but don't worry about how the implementation. You can always look at any book and get this implementation, unless you have been implementing it a couple of times. So you start with a guess. Okay, it's a standard method that was developed a long time ago, several centuries ago. So you have an integer 0 to keep track of certain values. Okay, and then go and change your guess. Okay, so basically you now say you guess as long as your guess square, when you square your guess, not equal to x and I is less than 20. There no numeric. You have a Newton-Raphson method for those that study engineering must have heard about that. Yeah, we have other method of guessing, but don't worry. I'm just trying to just quickly put this out a way we can implement our own square roots. Okay, there are a couple of ways, but this one is also not bad. You divide by 2. So probably nobody will ask to implement this without looking at anything. You always describe the algorithm for you to implement. Okay. All right. And then, yeah, at the end, you just return the guess. So the guess is actually changing, right? The guess value, so you start by guessing the value to be the same value as the square root.